Good afternoon, everyone, and welcome to our webinar about longevity and how research is shaping the future of aging. My name is Emil Werns, and I'm delighted to be your host today. We will dive into this fascinating world of longevity research and explore how cutting edge advancements are reshaping our understanding of aging. Joining us today, we have two amazing experts who are at the forefront of this field. First, we have our founder here at Supertrends, Lars Tvede. He is a seasoned futurist, serial entrepreneur, best-selling author, and has a deep expertise in identifying emerging trends and their impact on our future. And alongside Lars, we have Victor Björk, a physician, longevity expert, and research scientist focused on aging and life extension technologies. Together, Lars and Victor will share their insights into the science and tech and opportunities emerging in the field of aging. And the first part of this webinar is a 45 minutes discussion between Lars and Victor. And after that, we will have 15 minutes for a Q&A session. So feel free to post questions in the Q&A section throughout the webinar. Enough from my side. Let's dive in, and I will leave the screen shortly and hand over to you, Lars. Maybe you can start by sharing your perspective on the current state and future of longevity research.
Thank you very much. So first I'll say that you were so kind to present me as an expert on the field. I'm not sure Victor will agree on that. I have, as I told Victor, I have, together with a potential co-author, submitted a book proposal for a sofa table or coffee table for my book about the long, healthy life. That's not really because we're experts. It's just because we like to write books, and then we'll talk with the experts. But I've seen this theme getting, invading my life in a positive way. I could say there was a few months ago, I had a meeting in UK with a gentleman who was full of life. He was very athletic, talking about some huge business prospects that he had, and we spoke for, I think it was 3.5 hours. Very, very lively conversation. And during the conversation, he told me that he was 83 and he had hired a consultant to help him to become 120. And actually, so he had filed last will, but he was concerned that some of the people who should inherit his money would not outlive him. So, so that was one experience that uh, these kind of things would always stimulate other people like me, for instance, because I'm thinking I want to do the same. And then I hang out with some different people socially. Most of them are entrepreneurs, but also some business leaders, and I've seen them change lifestyle quite a lot on average over the last, say, 5 years, especially. And when I talk with them about why, a part of why they do it is that they're beginning to believe a little bit that if they can just stay alive and healthy for, say, 10 more years, then the cavalry will come like in the Western movies with fantastic medication, and then maybe they get 100 bonus years after that. So I don't think any of them feel completely sure, but they're beginning to feel that it's a possibility. And of course, there's also, maybe you don't get 100 bonus years, but maybe you get 20 bonus years because of the stuff Victor and his colleagues make. So uh, so if I can just frame it a little bit more, so we all know that there are different things you can do to be healthy right now. So you can sleep well, you can eat and drink well, you can exercise, you can try to be happy. Being happy is good social relationships, but also working on something that you find interesting, and maybe doing sport, whatever makes you happy. But then there's something that, Victor, you are not doing research in health testing, are you? Like the,
No, no.
yeah,
No.
but I think it's a part of the story, because the things you can do right now to live a healthy life. There, of course, we get a better understanding of them all the time. But there's this new range of technologies that actually, to a large degree, work already. So, Victor, will you take us through them, or shall I? Will you give it a start?
Yes. So of course there's very little human data when it comes to anything beyond diet and exercise and sleep and stress management. But there are many interventions that they can extend life and improve health in mice. For example, the drug rapamycin is a gold standard. It's approved for organ transplants in humans, but it's not approved for any aiding purposes in humans yet. But it always extends life in lab mice. So there's a community that is exploring that further. There's a diabetes drug that is very common and very cheap called metformin that also extends life and there's some human data also showing improved health outcomes from people taking it. And there's also a huge research field that are trying to develop more intervention and translate new findings into humans. For example, you can kill off senescent cells that's essentially like damaged cells that are too old and don't divide and participate in the function any longer, and they linger around and they cause aging. And if you remove them, you get healthier, at least in lab mice. And there's some human clinical trials ongoing there. So there's a lot of fields, both of things that you can potentially start doing yourself, and if you have the data, and things that are potentially emerging from the market as well.
So I think it would be super interesting to drill into some of these in more detail to understand them. But I just, if I look at what my friends do and some of what I do myself already now is, for instance, I do I take a huge blood test like two times a year on average or so. And normally, I mean, the blood test would be just for minerals and vitamins, and maybe for there's something called super for for inflammation, general inflammation in the body. But you can also screen for very early signs of cancer. How many, if you do, this is called liquid biopsy, right? How many different cancers can you screen for in one blood test?
I don't know that actually on top of my head, but quite a few.
Yeah, I've been told, like, I mean, if you take the full package, it's something like 50 or 70 different kinds. And there's something about cancer that when I've been reading on about this that I was not aware of. I thought, okay, so you have a local cancer, and you hope that it has not spread, but apparently they all spread. The point is that even if you have an early stage cancer and spreads a little bit, the body normally handles it until it becomes overwhelming. So anyway, so you find very early traces of that in their blood, and then if you see there's something wrong, then of course you look specifically for where is it and what do we do about it. But then you can do full body MRI. I've never done that, but that's I mean, if you do that, you can look for signs of cardiovascular disease, especially looking at the heart. But you can also look for problems with the veins, with the tendons, lots of other things, and catch things early. Then people wear wearables. I don't know. Do you use wearables, Victor, like a watch or step counter or a little ring or something?
A few, but not very advanced, I admit.
Right.
So,
Okay. So I have. I see quite a lot of people who do that. Some of them they do it maybe for 2 weeks to learn about their body, and then they take it off to not be too focused on health, and then maybe after some months they try again, and so on. So just to learn how the body reacts to the morning croissant and the evening wine, or what destroys your sleep and what doesn't, and so on. And then so one of the things that we know a lot about in Supertrends is AI. and we expect that 2025 may be the year where personal AI breaks through, where you have this AI on your phone that you can allow to know you really well, and of course that AI can, in principle at least, it can take all such information and put it into a kind of wellness panel that tells you what's going on in your body, what you need to adjust. And you can also do full DNA sequencing. I haven't done that, but I know a lot of people who have. And then you get advice based on that. I don't know what is your opinion about. Is that a mature technology?
Well, it depends all on the studies because many, if you could call it biomarkers for aging itself and not a particular disease, are still a bit under the debate, which is actually the best proxy for actual aging to intervene in, and that represents a disease before the disease is really there yet.
Right.
So AI is super useful, but it's only as good as the data you have programmed it with to begin with. So.
Yeah, I mean, you hear that's quite a few years ago that I first time heard about women who gets such a screening, and then they get told that they have a really elevated risk of getting breast cancer, and then they get a breast amputation and implants in order to avoid that. But what I hear from people I know is more about nutrition. They tell them, eat this, not that, and I don't know how valuable that is. But I have a daughter who she loves meat. She has always since she was very small. She really loves meat, and then she went and did a test like that, and then she said one of the outcomes of the test was that she should eat a lot of meat. So she kind of got confirmed why she felt so good when she was eating meat. But then, okay, so these are technologies to look for if there's something wrong in your lifestyle or maybe some bigger health problem growing, and then there are also some medications that you and I have spoken about already. There are some exciting medications coming up, like cancer vaccine, where let's say that you discover from your DNA that you do have an elevated risk of some specific cancer, then in principle you could actually do a vaccine against that cancer. So if you get it, you will not discover it. You raise your hand when I say something wrong, Victor. But then there's another area which is what you call reverse vaccine. There are three big areas that typically kill people. Eventually, there's cardiovascular, and then there's cancer, and then it's autoimmune diseases like Crohn's disease or diabetes.
Yeah, to some degree, it's also dementia is very big as an indirect for frailty, the inability to fight off infection, you could say, like
Is
immune.
that also a common problem?
That's a very common in the really old, like the people who are like age 90 plus, weakening of the immune system.
So all right, so so they die from a common flu.
Yes, yes. So secondary to their immune
So
problems.
there has been within the last year or two some fundamental breakthroughs that indicate that reverse vaccines will be developed over the next years. So you can, for instance, get a vaccine against diabetes too. But it's not working yet, but there's I think the community believes that it will work, and then step by step they will roll out these different solutions. So lots of things you can do to stay healthy in general, to screen your health, and if you have serious problems brewing, we'll have fairly quick development in better solutions all the time over the coming years. Also because of um, AI technology for analyzing protein folding, chemical reactions between different protein molecules and so on. AlphaFold, IMSFold.
Yeah. Yes, indeed. So that's a main part of aging as well. That's the what you call loss of proteostasis. So there's a problem with the protein manufacturing in the body, and you accumulate proteins in the wrong places, like amyloid beta in the brain, and the tau protein, and transthyretin amyloidosis, like a protein. A bit like atherosclerosis, but you get these grains in your cardiovascular system, which makes the heart struggle with pumping when you get really old. And in theory, you could start breaking those down with the antibody therapies. So then you can really talk about intervening in fundamental aging processes.
Yeah, so that's where I think we're getting to that now, because these specific anti-aging medications, they're all medications, I guess. They There's nothing, I cannot go to my doctor and say, give me some anti-aging injection or some anti-aging pill. Not really. I think most doctors would say, I'm not sure I know what you're talking about, but I can soon, right? Can you take us through, in maybe in chronological order, what you think is going to work over the coming, 5 years, 10 years, 15 years, perhaps? I know it's these are all wild guesses, and explain exactly what it is.
Yes, that is indeed a very hard question to answer because predicting timelines is notoriously difficult because
Yeah.
we don't know how it is going to translate, and if there turns out to be serious side effects, things are going to take a lot longer probably for any approval. And But I do think that if we are going to live significantly longer and healthier, we need to use multiple interventions in the same individual, like plugging many holes at once, because the issue with when evolution has set up the human body, we accumulated the different types of aging damages at a very similar rate. So when you're 90, you have a misfolded proteins aggregates in your body. You have loss of stem cells. You have senescent cells, and of these things accumulate at a very similar rate. So an old person has a lot of all these things that has been accumulating at very similar rates, and that's why they get all these diseases at roughly similar rates with a little bit of individual variations. But of course, there's nobody that naturally lives to 200 because of these issues. But that means that in order to achieve a significantly longer health span than we have today, we would need to do some kind of combinatory treatments. And There's actually very few companies that are doing that kind of research. Um, but uh, but in theory, you would need to design clinical trials also, where you, for example, clean senescent cells from an individual and use technologies to break down misfolded proteins to prevent Alzheimer's, and stem cell injections for repairing or an organ, and so on. So it's going to be very interesting to see how these synergistic therapies could potentially generate a longer health span. So
Right. So can you take what you see? And I think we all understand that you are guessing in terms of timeline, and also, yeah, one thing is to develop a medication, another thing is to find out that there are side effects. For instance, maybe you get
yeah.
more cancer, you live longer, but unless you get more cancer, and you're actually likely to get more cancer or something like that. But can you what do you see as the most promising in terms of how helpful it will be? Think about me. I would like to slow my health, um, and I'm not that young anymore, so I'm slightly impatient.
Yeah,
And also, what seems to be most in reach to become a real approved product?
yes, there's definitely some spaces that are more, you could say, crowded right now than others within the field of anti-aging. For example, senolytics, to drugs that kill off senescent cells. And there's a lot of companies in this field with various approaches because there are different types also of senescent cells. And so that's not one group, but it might be, for example, that you can use uh, drugs that have been developed by multiple companies and apply them at once in the same person. So you will need to take multiple medications at once to eliminate the different types of senescent cells and reduce them to a more youthful level. And But I do think over the next few decades, there's definitely going to be a lot of. It's going to be extremely interesting because there's a lot of things that are going to be translated, and if it turns out to work, then people are going to really want to demand it. Is going to lead to a lot of media attention and public awareness. uh, for sure. So, but I do think definitely anti-protein misfolding drugs and
Excuse me, can I just
yeah,
go back to these senescence cells?
yeah.
So you say that there are many different kinds. So I'm kind of interested in what which different kinds, and also how do you kill them without killing the good cells? What I mean, without getting
Yeah.
incomprehensible. Can you explain?
Yeah, that's actually a very difficult question to answer because there's no universally agreed upon definition of what a senescent cell is, except the fact that they don't divide and they secrete a toxic combination of chemicals that leads to chronic inflammation in the body. Uh, so, so in order to kill off as many senescent cells as possible, you will need to have the properly identified targets, which we know would differ. It depends on the tissue also, um, but it's not going to be one single drug for all types of tissues. However, we already know by the mouse data that, for example, the leukemia drug dasatinib combined with the supplement quercetin, that is a very common supplement sold in healthcare, uh, they reduce the number of senescent cells sufficiently to generate an improvement in a clinically measurable improvement, like restoration of fluor in mice and improved cardiovascular function and less osteoporosis and so on. So we know that the drugs that currently do exist, at least in mice, can partially reverse this process. But of course, with more drugs, you can do it to a greater degree than currently, in theory,
Oh,
by
so how do the drugs discriminate between healthy cells and defunct cells?
uh, different molecular markers that's quite hard to go into, but different molecular markers that the senescent cells display, but that are not present on the normal cells, which
So it's just
selectively kills.
some shape or some specific protein structure on the
Yeah,
surface of
protein.
the cell
Yeah.
that would tell it that we need to kill this one. And
Yes.
how does it murder such a cell?
Yes, exactly. So it triggers it to commit suicide, because they, without, preferably not by harming normal cells. But it should be noted that it's entirely possible that current senolytic drugs are also harming normal cells. The only thing that we know is that the clinical improvement in mice is greater than if you don't treat the mice.
Right,
You
the
get a
net
healthy.
effect is good. Yeah.
Yeah, the net effect is good. So,
So
but
how long have we been helping? I don't think we are helping mice when we experiment with them necessarily, but how long has this worked on mice?
it's very new. It's a very new discovery. The first study was done in 2011 that proved that you could partially reverse aging by reducing the number of senescent cells and improve the health span. So I would say that was a bit of a breakthrough, because that opened up an area of research that people did not believe in currently.
Mm,
And I do believe we are going to see many more areas like that opening up. Uh, that you get a new space in biotech that people
mm.
did not anticipate, and then it will rapidly get crowded with companies and academic research, and people will aim to milk it as much as possible and get therapies out.
Okay. Okay, so let's say that,
Yeah.
let's assume for a minute that it works as well in humans as it does in mice, and you give it to me.
Yeah.
Would I look better? Would I
Yes.
look young? I
Yeah,
would.
yes, I think if it worked that well, a person who has no scientific knowledge whatsoever will be able to meet you before and after and perceive you as better off and fresher looking in that regard. So I think it's a fairly obvious clinical improvement that you get, at least in mice, that you can also see.
Is there a place on the dark web where I can buy some injections?
No comment on that.
Okay, so you said in 2000, so the first hints that this was working net on mice was in 2011. We are now in 2024. What is the typical timeline from such a, I know that can vary a lot, from when you get the first hint at animal experiments until it becomes a clinical product?
15 years. It's often 15 years and $1 billion. So that's a very rough time frame. So And
Okay, if I add 15 years to 2011, then we're really close.
potentially yes, but the companies picked it up a few years after the first academic discoveries. So 2030, maybe I can be optimistic that
And then
if they
somebody somewhere improves it in the US or EU.
Yes, I would hope for something like that. That might be a very narrow condition
Mm,
that it gets approved of, and then potentially it will be repurposed for more general aging. That is often the hope, because aging itself is not considered a disease, so you cannot go simply
right,
after that as a target. So
right. So okay, so that's one that you think is very promising.
yeah.
And so, could you what would be another one?
Um, Yes, so there are multiple targets that you could say improving mitochondrial function. Mitochondrials, the energy production in the cell decreases with
Mhm.
age, and it
Can we take
contributes.
that? Just focus on just so mitochondria actually they used to be bacteria, right? That
Yes, yes,
in
indeed.
the millions of years ago they were absorbed by some
Yeah.
eukaryotic cells. And can you just explain what their role are and why they are a weak point in our genetic and biological makeup?
Yes, definitely. So mitochondria, they what they do is that they what happens with age is that they decrease their function. They produce ATP, the energy production in the whole body for our metabolism, and it declines with age, which means less energy and decreased muscle mass and organ function. And if you can potentially upregulate them to be more efficient, like in younger people, then you can potentially live a bit longer with that. So that's a big space as
Okay,
well.
so just to my knowledge, you can correct me here, but so the I know that genetically they are only inherited from the mother,
Yes, correct.
and so they don't have the genetic kind of repair mechanism that you have from sexual combination. Uh, we have a similar problem with the Y chromosome that comes only from the father. So,
Yeah.
as I understand, they are fairly vulnerable to genetic defects. Is that right?
Yes, they acquire mutations as
Yeah.
well, and their
Uh,
genome gets.
okay, so I have these. So these are these small organelles inside every cell in my body, in the blood cells also. No, right?
Uh, I don't have most cells definitely.
Yeah, okay. Most of the cells have these, and they are the ones who deliver energy, and then they start to malfunction. So what do we? How can we help that? What Can you explain that because it sounds really magic?
Well, yeah, you can stimulate mitochondrial biogenesis so that you create more mitochondria, and you can also improve the quality of their functioning with multiple targeted drugs. So that increases energy production as well. And one of them that is often sold as a supplement, that is NAD, because NAD production goes down with age, and there's some mixed data there if you can potentially improve age-related ill health by boosting NAD levels.
And that is something people do now, right?
Yes, that is definitely something people do. I would say it's a very unclear area to what degree it actually matters when you do it in younger people, because a lot of people who take these supplements, they are not very old. It might be more useful if you give it to centenarians than people
Mm.
who are only in their 40s and 50s.
So
So
if I take a blood test to find out if I need that, would I be able to see that from a blood test?
yes, there are tests to measure that. But I would say that this is one of the more debated areas in aging research, to what degree this actually translate into a clinically measurable
Right. Okay.
outcome. So
Okay. So it exists, but we're not sure it works.
yes, indeed, and of course the extremely old people are the one who would benefit the most from
Right.
potentially a theory at least. So.
I'm hoping to become an extremely old person. So, um, tell me about another one. This is interesting.
Yes, so. Uh, One thing that you can also do is you can break down potentially atherosclerotic plaques. There are multiple companies that try to work on this area, and it is now understood that, for example, lowering cholesterol is far from sufficient to avoid atherosclerosis. It happens throughout life to most people. Actually, it does not really happen to everybody, because there are cases where people have been over 110 and not developed atherosclerosis, so actually had perfectly clean arteries. But most people develop atherosclerosis regardless of lifestyle to some degree, and uh, and there are ways of intervening in that process. One of the things that you can do that is currently a bit actionable, apart from lifestyle, is trying to lower this age-related chronic inflammation, because what happens with age is that the level of chronic inflammation goes up in response to the tissue damage that accumulates with age, and also aging of the immune system, and many other factors. But you can measure even in healthy older people that they have an increased amount of inflammation than younger people, which is often correlated with cardiovascular disease and the development of cancer and many other conditions. And we know that that many drugs that improves the health somewhat of older people and are disease protective, they actually lower inflammation. Even statins don't only reduce the cholesterol, but they decrease inflammation also. And some people have proposed that is also an additive effect for why statins reduce cardiovascular incidents, that they also lower inflammation.
Okay, so I have a question about inflammation, because
Yeah.
let me explain you. So I understand that chronic inflammation means that the body is so preoccupied with fighting something all the time that it doesn't have excess. Maybe I'm saying this wrong, but it doesn't have excess capacity to catch these potential cancerous cells, for instance, or other more serious things that are going wrong. And for instance, many people have a little bit chronic inflammation from the gums because they're not using cleaning their teeth well enough, for instance. Or you can have it from, as you said, these cells that are in your body that are malfunctioning, or from drinking half a bottle of vodka a day or whatever, smoking. Um, so I understand that. But then here comes where the story gets more complicated, because if I do hard sport, then I'm ripping my muscles apart. I probably have internal micro bleedings, lots of places. I'm poisoning myself with radicals, chemicals that are damaging my body and so on. But that's healthy.
Yeah, I mean, inflammation, short-term inflammation is great because it's wound healing and it repairs muscles when it comes to exercise. But it's this low-level chronic inflammation that is persistent 24 hours a day, and it increases with age. That is what is the dangerous one, the sterile inflammation that they call it, that is not in response to any pathogen and not in response to any controlled tissue injury like exercise and so on. And so I want to point out that inflammation is very complex. There's a lot of different molecules involved, and many of them increase with age. So uh, so some of them are believed to be more harmful than others, and they also increase in conditions like obesity. For example, very obese teenagers, they have already elevated inflammatory markers in their body compared to other people of their age. So
So,
it's not
so
only.
shouldn't it be more common than it is to get tested for chronic inflammation? So you say every person on the planet has some chronic inflammation, but the question is it very low or is it elevated?
Indeed, indeed. So in theory, you could argue then that the optimal amount of inflammation is what you observe in a healthy 20-year-old, and anything above that is suboptimal,
Mm.
and that should be fought with biotechnology. You could say in that regard.
Yeah, so you should first find out where does it come from, and then see
Yes.
what you can do about it. Yeah.
Yes, yes. So I mean, it's infections that the body fails to fight off, like cytomegalovirus, for example. Cytomegalovirus is harmless infection, but the body uses a lot of immune resources to fight it off, and it depletes the capacity of immune cells to that should have been.
So what is a, let's say you take a 40-year-old,
Yeah.
what might be a sign if you don't haven't done the blood test, don't know the number, what might be a sign that you have too high chronic inflammation? Might, is it that you get flu too often, or
No,
is
it might be rather silent still, because 40 is also relatively young. But you with an increased level of inflammation, you more easily develop plaques in your arteries at a relatively early age. But you
so
need
that you would not necessarily know?
no, you will not know that likely before you have a stroke or heart attack,
Right.
because most people don't check it. And it's not necessarily that you have a lot of plaques just because you get a heart attack. You can have a very moderate amount and then it breaks off and you get a heart attack. So it's not always that detectable early on.
But yeah, there are these people who are never ill, and then
Yeah.
there are these people who get flu 5 times a year. Does that have anything to do with that, or is that something else?
Not necessarily, because people are also based on their immune system and the receptors on their immune system, they can be more and less likely to catch a cold than others. But that doesn't necessarily determine the rate of aging. That you have not missed a day of work in 30 years is not necessarily an indication that you're super healthy from that angle. And it's also, of course, about exposure. I mean, if you work in a kindergarten, you're likely to get ill, for example. So
Right. Okay. Um, okay. So how does the things you can do against plaque? Can you explain that?
yes, so what you can do currently definitely is to avoid excess blood glucose and excess uh, lipids in your blood, many others people don't think about is that you need to lower your inflammation. You can, for example, check CRP, C-reactive protein. That is a very general marker for inflammation, and if that is too high, that's a sign that you're more likely to develop cardiovascular disease, even if you are of normal weight and so on.
Mm,
So you should definitely track that. And if you go into an advanced level, you can look at things like interleukins, which are inflammatory compounds. And there are many other more advanced tests like that you can take and get some kind of insight into your cardiovascular risk from that regard. And people who have less inflammation, they age slower in that regard. For example, in Okinawa in Japan, where there are many more people who live to 100 than elsewhere, they have a much less chronic inflammation than people in the Western world with a Western diet. So
okay.
that's
So,
definitely.
but is medications that you would call anti-aging medications for this in the pipeline, stuff that we don't have now?
Yes, definitely. There are companies who work on addressing and dampening down uh, inflammation in that regard. So I want to point out here, because this is of course a bit of a chicken and egg problem, because inflammation increases with age, and the inflammation also causes aging. So it both causes aging and it drives aging. Uh, so it's really chicken and egg problems. But if you artificially dampen it with a molecule, that's the net outcome is generally good.
Right.
So
Then we have the telomere. Like, can you explain what that is at the end of the DNA? When
yes,
this,
definitely. That's also one quite unclear area in aging research, I will say, because telomere is also a bit of a chicken and egg problem, because telomeres, that's the end of the chromosomes, and they shorten with age. So in really old people, there's almost nothing left. Uh, but
almost nothing left or nothing left?
well, very little left at least. So
Yeah.
but it's not it's something that varies a lot between individual cells. So if you will go into tissue of a 90-year-old, you will see some cells that have virtually no telomere left, but some with more. So it's not necessarily that it's the same in every cell. It's not like a ticking
And
clock.
then when the cell divides, then you actually use coding genetic material because you don't have this protection left.
Yes,
That
if you will go to that degree, yes.
okay.
um,
So there's something called the telomerase.
Telomerase
Yeah,
is the enzyme that increases that,
yeah.
but of course it fails to do it at a pace that
Right.
is enough to
So,
offset.
is there anything we can do about that in the future to extend our lifespan? Because I understand that people who are naturally
Yeah.
genetically, for genetic reason, born with longer telomeres age slower and live longer. Isn't that right?
It's associated with better health, yes, and there are some studies using gene therapy in mice that show a small life extension of about 10% by creating mice and artificially creating very long telomeres by telomerase gene therapy. So it's definitely a component of aging, but it's also secondary to other damage in the cell because telomere shortening responds to other damage. And there's also studies showing that people who exercise and live healthy have a longer telomeres than others.
So let me just get that. So if you live healthy, so the body has a repair mechanism to build them back out when you lose some of them. Is that right? And
Yeah,
then if you live more healthy, then it does that better, and
yeah.
then you are less likely or more slowly get a problem from them being too short.
Yes,
But
early
you can
on, yes.
also, in a pharmaceutical way, on mice and perhaps in the future on people, give that process an artificial boost.
Yes, I will expect that giving an artificial boost to people in that regard would give some level of health benefit, but I expect it to be quite moderate because it's only one component of these
Right.
different markers. So,
So can you like we don't have so long time left for discussion before questions, but can you just list what else, what other things you think are very promising, and what are you working on yourself?
yeah, there are many things that are potentially promising, but it's very hard to make a speculation of when it's going to
Right.
reach the market. Actually, so I have to be a bit of an agnostic to say that I favor X and X
Mm.
treatment. But despite that, there are more technologies that are more mature than others. Um, and Well, what I do myself is I help people who invest in this area to evaluate companies in the field if they have good technologies or not. And I also help people who are very interested in their own lifestyle and so on, and want to understand the space better of what is possible to do nowadays. Because, for example, there's a lot of longevity clinics that are opening up now in the world that are offering treatments, and some of them might have some truth and some of them are hype, and it's important to be aware and know where is actually the latest science.
Right.
uh,
Mm.
am I doing a reasonable bet here or not? uh, so that's one of the things I do as a geroconsultant, as I call it. uh,
And what,
ger-
what, what
Gerontology, so aging.
so
So
what kind of clients need that from you?
people who visit longevity clinics, people who invest, people who are very passionate about their lifestyle and also want to understand the things beyond diet, exercise, and sleep,
Hmm.
and so on.
Yeah. Mm.
So I work as a concierge, you could call it, to help people, and I also evaluate other people like physicians and other scientists who are.
Okay, so you have individual consumers who are really into this, and then you have investors.
Yes, indeed. So both of them. So both from corporate and
Okay, so
private.
yeah, that means you have a great overview of
Yeah,
everything. So I I have a last unless you wanted to list some other things that are in the pipeline that we haven't.
I can very briefly, I
Yeah,
can mention
do that,
cellular
and then I come with
reprogramming.
my last question. Yeah.
Yeah. So cellular reprogramming, that is a technique that has become hugely popular in the aging field, and that is that you partially reprogram a cell to reset the instructions in the cell so that they resemble more youthful version of themselves, and so you can potentially use that technique to reverse aspects of aging by inserting more youthful cells into a tissue. And there's some companies that are working on that, like Altos Labs, which received an initial funding of $3 billion, which is the biggest
Hmm.
funding in biotech industry, single funding.
So
So,
where would you inject that?
you can potentially inject that in any type of tissue that you have adapted it to, that have suffered from a loss of stem cells and the function.
With that versus cartilage, most people get problems
You
with.
can use it in cartilage, the other cells. You can use it in bones, in muscle, and you could
Runs,
repair and age the heart with it. But it's not enough to reset aging itself because it doesn't remove the junk that you accumulate, for example, in tissues. So you need to
right,
clean out the junk and restore the cells that are
right. Yeah, we
so.
all end as a pile of junk.
Yeah.
Okay, so my last question is just that Orbit de Grey, he coined this term longevity escape velocity quite a few years ago. And this is about, well, maybe you can explain it and you could tell me if you believe that we will ever get there.
Yeah, so longevity escape velocity would mean that you are able to successfully implement enough rejuvenation technologies into people to make them live longer to a degree that they essentially never have to experience aging, but they can dramatically extend
Right.
their life. And as for knowing when that will happen, that is first of all, it's completely impossible to know it in advance. So you can only know it after that has happened, and a long period also after it has happened. So
Right.
I cannot say it's going to be in March 2043 because it might be decades later we can see, oh, this actually happened at this inflection point.
Yeah, people start walking around saying, why
Yeah.
is she still around? She was also around when I was small, something like that.
Yes.
Yeah.
Yes, indeed. So it's hard because it's going to be when do
So,
you
so
actually
do you,
plug
but
enough
do you think
holes?
it's possible to get to that point?
Oh yeah, definitely, definitely. And it doesn't violate any law of physics. We actually do not know to what degree that you would get if you would combine all the technologies that we have a hint of that might work into one individual because it
Mm,
has not been properly done. So, but at
mm.
some point, I think people are going to aim for that, and we no one knows what will happen.
Right. So do you think?
Very, 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 very interesting, guys. It's tough to cut you off now
Right.
at this topic, but but I need to do so
Yeah.
because we need to open the floor
Yeah.
for some questions. So again, the audience out there, if you have questions, please post them. But we already have quite some, so let's see how many we can cover. Um, the first question being, any thoughts on the new AI supercomputer that has been launched in Copenhagen and its ability to aid in this topic of slowing aging? Maybe you can start, Lars, and then Victor, you can chip in also.
But I start. Okay, that's the Gefion. I was actually supposed to be at the opening ceremony, but couldn't make it. But I just want to. I don't think I should be the one to answer that, other than saying that the discovery process for protein folding and protein chemistry has increased more than a million x because of AI combined with supercomputers. So that's all I want to say about that.
Yes, so I cannot either comment on how quickly it is going to solve any problems that in that regard. Just that it's very impressive what is going on, and there's so many things opening up now, so we don't know where it's going to lead us in a few years only. So
No, only that these kind of technologies speed up the scientific development massively.
yes, especially if it does it by the boring work that people have to do manually gets wiped out, and
Yeah,
that's why
yeah.
it needs to move so quickly.
And you are less likely to pursue a dead end avenue because you can do in silico testing, as you say. Computers can find out that this won't work because it will cause this problem, and then you don't have to go through clinical trials and all the rest of it.
Thanks for your thoughts on it. I guess the future will show what impact it will have. Jumping straight to a new question because there are quite some. Question from the audience here. How can someone balance the immediate health goals with long-term anti-aging benefits? Maybe you can take that one, Victor.
Yeah, I mean, nobody has any answers because we don't have any detailed map of the molecular composition of a human body in that regard. We don't have a roadmap of everything that goes wrong with age. So it's very hard. There is no answer to that. Everybody has to make their own risk-benefit calculation based on the currently available scientific evidence. That's all I can say from that.
But there's no contradiction at all between short-term health and long-term health, right?
Not really, not really. I mean, of course, you can argue that some people or Olympic athletes might,
Overtraining.
prioritize performance over longevity in some regards. But for the general population, there's not really.
Thank you. Thank you. A question on how long are people born today likely to live? I guess that's also a question of how much longevity can impact the age we can get to.
Yeah, that's a very speculative question because we already implement many medical advances that we couldn't do before, and things are going to improve incrementally. So when is enough? When are we going to do enough to really modulate lifespan to a greater, more significant degree? What if you, somebody who would have lived to 88 can be treated with an immune booster and live to 103? When do we draw the line between what is actually an anti-aging treatment and just preventing a particular condition? And it's a very speculative area too.
But you just say somebody who's born today, when that person begins to become kind of old, let's say 60, 70, 80, an absolutely massive amount of progress must have been done.
Oh
It's what.
yes, definitely. But in the lab, it's also the issue of implementing things because there's so many interesting findings in the lab and the cool data that is also not really picked up upon and are sometimes just left, and you would be surprised to discover that this condition could be improved 5, 7, 8 years ago, and but where is the new research picking that up? So you would need to really, it's almost like going into a gold mine and looking why is nobody doing that, why do you have this web of
Yeah, which AI can do, by the way.
yes, definitely.
Thanks for your take on that. I think that brings us over to another question that has popped out different versions. But overall, what do you see as the biggest challenge in bringing anti-aging treatments to kind of mainstream markets? So
Well, I mean, it's very expensive, and aging itself, we need better markers to conduct a clinical trial, saying that we are getting to the point where we reverse aging and not treating a particular uh, condition only to that degree. And then also things like compliance is very difficult once you get something out. That's surprisingly difficult. Is somebody going to take hundreds of pills every day and never forget anything, and in order to live longer, for example? That's also a thing. But costs go down fairly quickly after something has been approved in most cases, and because there's going to be such a big demand, that's for sure. So,
do you
yeah.
think we will get to that stage where it is a mainstream market to all these medications and stuff?
Yeah, there's
Or
going to
will,
be a push for that definitely because the HA diseases are so extremely expensive. So the push is going to be that it's not going to be just for a few people, and that is irrespective of any discussion about moral and ethics. It's a pure economics that it's very expensive to be ill, and that's why people are going to try to get to that point.
I would like to say that if you look at big investment banks and research companies' predictions for real GDP per capita in the future, they think that trend growth will kind of tilt up because of AI and robotics. And as we get more wealthy, we will allocate more money on average to these kind of things that really can increase life quality. But there's also a cultural element. So if you see your friends do it and have some success with it, then you're more likely to start pursuing it yourself.
Yeah, and not to discount the general state of the economy in the world, because of course, if the economy has to be great in order for us to pursue these expensive things that are, high the you say Maslow's pyramid, so to speak of.
Yeah, yeah.
Thanks a lot. Thanks a lot for your thoughts on that. Um, a question on how do you conduct clinical research on aging? since it's not guess the question, since it's not an official disease. So what is the process of that? And does that yeah.
Yeah, if I just have to give my personal opinion on that, that might be contested by others, but I think there are some fairly good diseases to go after. For example, sarcopenia, so muscle loss that happens with age, is recognized as a condition to treat, and that's, you could say, is a very universal feature with aging, because all 90-year-olds are frail; they struggle to walk. So it's more real aging than, you could say, cancer is, for example. In that regard. So I think diseases like that, immune response to a vaccine, that goes down with age. So immune response to vaccine, sarcopenia, frailty, ability to walk, because every biomarker that has to do anything with aging, in my opinion, has to be tied to physiology. So I think measuring age reversal is a very simple thing, because you are going to use very crude, simple things like how is your vision, how is your ability to walk, how do you feel. I mean, that's going to be the ultimate endpoint. The molecular markers for aging is not going to be the ultimate endpoint. It's going to be the simple, already measurable physiological endpoints that we already can do today, actually.
Very interesting. Very interesting. Thank you. A question here, and that's what emerging treatments or lifestyle changes in general are you currently most excited about in this field of anti-aging?
Uh, that are currently available, I cannot really comment because I cannot give like medical advice in that regard. But certainly we know that a lot of we would have a lot more people who reached 85 if everybody ate well and exercised than currently. That's for sure. It will wipe out a lot of premature mortality. Actually, unhealthy lifestyle, I mean, accelerates aging on a molecular level. So it's not very distinct in that regard, really. So.
Thanks for giving it a shot. I think there are many asking for tips and tricks in the audience. But thank you both. It's been really interesting. We've covered a lot of ground. But before we wrap up, we would really like to show a small video of what we do here at Supertrends. So we would stay along. It's short, and we'll play it now.
Hi. Our smart scans are tailored to each customer and their specific strategic objectives. Here's an example of a smart scan for offshore wind power. This example includes a summary of key developments, key market developments, the latest innovations and technologies, and other information of relevance to the specific use case. We can structure and deliver the information in many ways so that it fits your way of working, and once configured, the smart scan is automatically updated with the latest information. Our platform can also use the monitored information to generate a range of new content such as podcasts or a summary report on a topic. Imagine you ask for a report on energy technologies. Our AI assistant will then guide you to ensure the report meets your requirements, and within seconds, a report is generated for you, covering the latest information we have collected on the topic. This way you can interact with and extract highly relevant insights tailored to your business. Get in touch with us to know more about our different solutions. Thanks for watching.
We hope you all enjoyed a small sneak peek into what we do here at Supertrends, besides speaking about longevity. Again, we have to wrap up. Thank you very much, Lars. Thank you, Victor. Thanks to everyone joining in on this really interesting discussion. And of course, if you have any further questions, reach out to us and stay tuned for further upcoming events. Thank you all, and have a great evening. Goodbye.